Good morning to everyone. This is Nasreen from Physics Department. Today we are going to discuss about Unit 5 in electronics, which is named as operational amplifier. On short note, let us see what are the topics we are going to discuss about today. First is introduction, then inverting amplifier, non-inverting amplifier, voltage follower, log and anti-log amplifier, comparator, filters and converter. These are the topics we are going to discuss today. First introduction, let us see what is amplifier and what are the uses of this amplifier. Okay. First one is known as amplifier is an integrated circuit that uses external voltage to amplify the input through a very high gain. This is the first use of this operational amplifier. Then operational amplifier circuit designed to boost the power of low level signal. Then there are two types of operational amplifier. First one is known as inverting operational amplifier, second one is known as non-inverting operational amplifier. Let us see what are the things that we are using in this diagram. First one, I hope you can able to see the screen. First diagram is known as inverting amplifier diagram. This circuit makes use of an operational amplifier, a single resistor R1 connected to input and a feedback resistor R2 connected to R1. Then the inverting amplifier produces a 180-degree phase shift in voltage from input to output. Let us see the input and output waveforms of inverting amplifier. The first diagram that we are seeing here is known as inverting amplifier's input diagram. Then the second one we are seeing on the right side of the slide is known as the output waveform of an inverting amplifier. Okay. Then next we are going to see about non-inverting amplifier. The diagram we can able to see in the screen is known as non-inverting operational amplifier. This circuit consists of an operational amplifier, a single resistor R1 connected to ground and feedback resistor R2 connected to R1. Input voltage is directly applied through the non-inverting terminal. Okay. Then we are going to see about non-inverting operational amplifiers configuration. The configuration consists of R1 and R2 form a simple potential diver network across the non-inverting amplifier with the voltage gain of the circuit. Okay. First diagram we are seeing in this screen is known as input waveform, and then second one is known as output waveform. In the first one we can able to see here as 2V. That one is represented as 2 volt because 2 volt is using in this operational amplifier, so that we are giving 2 volt input in the form called a waveform, and then we are getting output as 5 volt called output waveform. Okay. The input voltage signal Vin is applied directly to the non-inverting positive, that is input terminal, which means that the output gain of the amplifier becomes positive. Okay. And then second is the result of this is that the output signal is in phase with the input signal. The operational amplifier can be short noted as an integrated operational amplifier circuit that performs the mathematical operation of the integration. Then the magnitude of its output is determined by the length of a time voltage is present as its input. The output voltage is proportional to the length of time a voltage is present. Then the longer the input is present, the greater the output becomes. One great application of the integrator is generating a ramp voltage. Then operational amplifier integrator, which is known as feedback component used as a capacitor. Okay. The resulting connection is called as integrator. Then the V out is known as the voltage output is equal to minus of 1 divided by integral omega RC into V in. This formula is represented as voltage output. After that, let us see what are the points and what are the things that that this operational amplifier integrator is doing. First one is the integrator work as a low pass filter circuit when the time constant is very large. Then W is equal to 0, that is the gain A is infinite for an ideal operational amplifier. Then at DC means direct current, okay. At DC, the capacitor C behaves as an open circuit and there is no negative feedback. Then but in practice output never becomes infinite. Then let us see about differentiator operational amplifier. That one is known as the also known as the output voltage is a constant, that is minus RC times the derivative of the input voltage V1. And then at a high frequency, a differentiator may become unstable and break into oscillation, okay. The input impedance, that is Xc equal to 1 divided by Wc, that is decrease with the increase in frequency. That's why it is represented as X suffix C equal to 1 divided by Wc. To overcome through the problem of instability and a high frequency noise, we use the practical differentiator, okay. The output equation can be written as V naught into S divided by V into S equal to minus S R of C1, the whole thing divided by 1 plus S CF RF into 1 plus S C1 R1. I hope you guys can able to understand what is amplifier and what are the types from this lesson. Thank you guys. Have a nice day.